Hello, everybody. Today, we're going to discuss the difference quotient, which is a pretty important thing because it is why we're going to have all these crazy rules eventually about derivatives and formulas regarding them. But the difference quotient is kind of like the DNA, the base of everything we do with differential calculus. Now, it has a couple other names, the difference quotient. It's also more commonly referred to as the derivative. They kind of are the same thing. And it also gives us the slope of the line tangent. Now, as far as notation goes, we can express things in a couple different ways. One way, as it says right here, is f prime of x. If f of x represents a function, then we definitely can use f prime to represent the difference quotient. And also, we can have dy dx. Now, we have dy dx if the function expressed is in terms of y. It's going to be f prime if the function is expressed in terms of f of x. In order to keep things simple, I'm going to stick with f of x right now. So f prime is going to be the difference quotient, which is also the derivative. Now, let me scroll down here, and there's going to be a little bit of a formula very similar to the one that we had yesterday for instantaneous rate of change. It's another way of expressing instantaneous rate of change. Now, if I just look at this without even knowing any kinds of function here, as h is going to 0, that guy's going to 0. You have f of x minus f of x, which is 0, and that's going to 0 too. So you could see that we have some work ahead of us. 0 over 0 is always what we're going to be looking at in terms of the difference quotient, if done correctly. However, we're going to do some algebra and stuff like that to kind of guide us through. I've got a couple examples. Boop. And over here, I just wrote on the right-hand side the difference quotient again, that formula. You should memorize this. Yes, you should know this. Yes. Okay. And by the way, this right there, that's crap. Ignore that. I don't know why it keeps showing up. So we're going to use the difference quotient to find f prime. That's supposed to say f prime over there. If f of x equals x squared minus 1. Now, some of you might remember when we did derivative earlier in the year and look at this and be able to say, oh, I remember how to do that. Can I just do it? No, you can't. You got to show this. This is the y, that rule that we did earlier in the year of why that becomes. And sneak peek, the answer is going to be 2x. Remember how to do that? If you don't worry, we're going to come back to it. But first, we'll do the difference quotient to really get the answer. So the limit as h goes to 0 of, now, f of x plus h. So that means you're going to plug in an x plus h everywhere you see an x in the function. So right there, that is f of x plus h. All right, and what I'm going to do is I'm going to put an extra set of parentheses around that guy. And this so I can space them out from f of x squared minus 1. And this guy's going to be over h. Alrighty. So let's see here. So the first thing I'll do is square out the x plus h. So we'll have the limit as h goes to 0. And when I square, that's supposed to be a 0. And when I square that out, we have x squared plus 2xh plus h squared minus 1. And then minus x squared plus 1. Remember, this subtraction sign, when distributed to the binomial, switches both the signs. This guy's all over h. Alrighty, so we're not going to do anything with the limit until we clean some stuff up, because you might notice, for example, the x squared terms are going to kapow, take each other out. What about those ones? They're gone too. Now let's just look at what we're looking at here. What's left? 2xh plus h squared all over h. Now, if you still plug in the 0, you're getting 0 over 0. So we're not much better yet. All right, so let's make it more better, more gooder. So stop moving around. All right, so equals the limit as h goes to 0. You can actually take a GCF of an h out of the top. And then that h with this h, zip, gone. Now, you may try to do the limit. As h goes to 0, 2x plus 0, that guy's going to equal 2x. There we go. That is f prime. All right, let's look at another one. There we go. I changed the function a little bit. Not a nice polynomial. I got a little rational guy going on here. 1 over x plus 1. All right, so let me see here. First thing I want to do is I want to make this everything a little bit bigger because this, that didn't really help. All right, so let's go for f prime of x, which is the limit as h goes to 0 of, now the function, f of x plus h. You're going to put an x plus h in there. 1 over x plus h plus 1 minus 1 over x plus 1 over h. Now, ladies and gentlemen, earlier in the year, we played with these things called complex fractions. That's what we're looking at here right now. That's a complex fraction. Now, the technique with a complex fraction is identify the LCD and multiply through the whole thing. So the LCD in this case is going to be both the x plus h plus 1 and the x plus 1. You need those little denominators in order to get in order to simplify the complex fraction. That's what I'm trying to say. Okay, so you're going to multiply the top and the bottom by this LCD. So here we go. Let me first start off by writing the limit. Let's get the h's going to 0. And now when I multiply this throughout here, in the first go round, the x plus h plus 1 is going to cancel, but that x plus 1 is going to be multiplied to the top there. Let me put them in parentheses. Minus. In a similar way, the x plus 1 here and that x plus 1 there are going to cancel, but you still have that x plus h plus 1. Now, in the bottom, you have h times x plus h plus 1, and then times the x plus 1. All right. Okay, let's clean up the top there because I see the subtraction between that stuff. And all right, so let's start with the limit. Let's go with h going to 0. Well, x minus x. Whoa, they're going to be gone, right? The x minus x is going to be gone, and the 1 minus 1 is going to be gone. So you will be looking at negative h up at the top, and then down below h, then x plus h plus 1, and then the other x plus 1. Looks a little ugly here in the beginning. Oh, wait a second. Look at those x. Oh, those h's. Boom, 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 boom. All right, here. So let's keep going. We got the limit. We got the h going to 0, and we have negative 1 over x plus h plus 1, and then the x plus 1. Now h is going to 0. Now let's try to plug in, and when we do, we'll get a negative 1 over. Now, since this h is going to 0 right there, you really have x plus 1 times x plus 1, also known as x plus 1 squared. So if you have a complex fraction, yeah, sometimes the work is a little bit more difficult. You just got to be careful. Give it a shot. See what you can do. Worst case situation, we can discuss this during our Google Meet. Bye for now.